launch it that way, it would maintain that same orientation coming up and then be flying sideways on the way down. So just as you touch off very lightly, you give it a little nudge so that it arcs over in flight, the Hail Mary. That makes it fly aerodynamically because you're approximately giving it the angular velocity in ballistics to match its parabolic trajectory pretty good. We're doing that with the ostrich, which is shaped like a football for that reason. Next, there's the plot. Here we go. And every biped does this. People do it. Running guinea fowl, ostriches, any size down to sparrows. That's the data. Next. Click on that. There's just no time for a neural impulse to travel. Neural impulses travel at highway speed. And we're running at highway speed. There's no time to get. So, all the stability we see is geometric, purely.
You need to come up with more words for highway speed than highway speed because you're using
I gave you dimensionless velocity. That's the technical term. But Jerry taught me that. Before I knew that, that's how I thought of it. So you're correct. Dimensionless velocity, then in excess of 4, we'll call highway speed just for the talk. That's the picture. Next. That's why the ostrich body bobs up and down as it runs. It's not even thinking about it. It's just in the throttle setting. It's all geometric. It's all simply mechanical. Next. And that's what we see when we look at this. The coordinates of interest are centered at the hip. That's just for the theronic grid. The metacenter is about 1.8 times the height of the CG for everything, and it varies by less than 5% up or down. As you go faster, it actually gets slightly more stable. Next. We have suspension. We have torque conversion. And so that converges to metacenter. Next. We can shape that curve, lock it to support weight in the region of interest, and we got it. Next. We're getting these kinds of clearances already that Russ Tedrake talked about in the video. More than 50% of leg height for 75% of the stride and a nice ramp leading in and out. That's phenomenal. At these speeds, no control. Next. We can excite this thing, Fourier driving, about the hip. We have only one actuator on each leg, one motor only. If it moves slow, the leg swings as a pendulum. But if I excite it at twice that frequency, now I excite this other mode, and that's how we get the duty cycle. Next. Now what I just did on live here, you can put your hands on and try. Don't slam the foot into the ground. I tied the rubber band up with that so it wouldn't happen, and so I didn't break the other foot. So, and I put it on soft foam. But you can try this, and we have the soft foam here. That's how this works. Just to give you an idea of the speeds we're talking about, doing this as fast as I can. And yes, it really does lock instantly to take load. Doing this as fast as I can is only dimensionless velocity 1. This thing should be going 5 times as fast as that, and you couldn't see it. But to get those speeds, I had to make it out of carbon fiber and super oscillate with a motor, and I'm waiting to do that next. Looking very much forward. Next. We're in the nonlinear oscillator range. The initial frequency doubles, doubles, doubles it again, and I'm not exaggerating. I'm going to show you. So we don't have a familiar Bode plot. It leans to the right, hard. So what we want to do is we don't want to control it with a script. We do not want a trajectory. All we want is a phase gain in the driving concept that I simulated before, and this thing will just ride up that curve. Next slide. So all we do is step on the gas. We don't have to think about it. It's built in. Next slide. Play that video. This is a 2-foot ruler surrounded by steel springs, progressively stiffer. This has got to play. Now at 2 feet, we're not even human hip height. How fast do you think it's going? This film is in real time and you'll need the soundtrack. Listen to the clicks. Please play. Swings back and forth like a pendulum at slow speed. Go ahead, expect to get a swing in 5 sequence. No one can go, then you go fast still. Notice that my hands are barely moving, so we're keeping our driver in the sweet spot. Very low driving deflections. How fast? Speed estimates, anyone? Need at least 3 guesses from the crowd. 2-foot ruler, going as fast as you saw. How fast is the tip of the ruler going What running speed would that correspond to?
100 miles per hour.
Actually, 104.5. We've got the stability of a mono wheel. We've seen that. We got spokes instead of a continuous rim, but it's so fast anyway, you can't tell the difference.